I'm going to take question 11, 12 and kind of deal with the most difficult kind of question that you can develop out of something like 11 or 12. Okay. They're going to ask you, they give you a picture here and ask you, can you come up with the algebraic rule that generates that function? Okay. So that right there is a 0, correct? So what is that? Okay, so that factor is x plus 3. Okay. Now, as you're doing these, you have to pay attention to the multiplicity at these roots. Okay. Whether we're tangent, whether we, whether we pass through like that. Okay. If it passes through like this, they will say find the polynomial of least degree for this particular function, meaning that this would be a third degree or multiplicity of 3 and not a multiplicity of 5. Does that make sense? Okay. We don't have that situation here. We don't have any multiplicities here, but if we were ever to encounter that. Okay, so this one here would be x plus 1, correct? This one here would be x minus 2. So when I want to find p of x, okay, p of x is going to be x plus 3 times x plus 1 times x minus 2, correct? Now that is per just my zeros right now. If I multiply that all out, okay, what would your constant term be? If you FOILed all this out, you would have 3 times 1 times negative 2 as your constant term, wouldn't you? So it'd be negative 6. What does our constant term of a polynomial always tell us? It's the y-intercept. Is my y-intercept in this picture negative 6? No. And I had to zoom out when I made this in GeoGebra, but it is at negative 12. So how do I make negative 6 turn into negative 12? Multiply by 2. So I have an A multiplier out here, okay? Sometimes we call it a scalar multiplier that would actually come into play here. That then, actually WebAssign will actually accept this typed in this way. They don't necessarily want it or need it expanded. If we do expand it, I'm just going to cheat a little bit just to save time, because I think we can all FOIL, right? If I expand f of x, okay, so x cubed plus 2x squared minus 5x minus 6. So remember, that is what we would have had by just multiplying the linear factors out. Then we need that a term to be 2. So p of x that would really be interested in here is 2x cubed plus 4x squared minus 10x minus 12. That's one way of doing it. Okay. Now I like this because they give me essentially an ordered pair here, 0, negative 12. Okay. There will be times when we see a graph. Let's see if I can generate one. So doing the same thing here. Okay, if I've got this as a 0, what is the factor? X plus 2. What's that factor? X plus 1. What is that factor? X minus 1. Okay, so P of X is going to look like this. X plus 2, X plus 1, X minus 1. Now, if I multiply those out, my constant term is going to be negative 2, correct? And that's obviously not what we're seeing right here. But even if I look at that one right there, that doesn't give me real good indication of what my y-intercept is. If I go back into GeoGebra where I made this, my y-intercept is going to be right there. Would anybody have guessed negative 10 and 2/3? No, okay? So it's not a whole number y-intercept, but what they do here is they give me a different point. They give me that point right there, right? I know that point is at an x value of 0.5 and a y value of -10, correct? Okay, so that's an x value, that's a y value, or a p of x value, correct? So what we would do then to find that number that we multiply the entire thing by, that scalar value of a, we take p of x, we make it -10. We don't know a, that's what we're looking for, but x now becomes 0.5. That becomes 0.5 there, 0.5 there, 0.5 there. Does that make sense, everybody? So what's 0.5 plus 2? 2.5, right? 0.5 plus 1, 1.5. 0.5 minus 1, -0.5. Does that make sense, everybody? Multiply all that out. So 2.5 times 1.5 times 0.5 gives me negative, because of this negative here, 1.875 times the a that's out in front is equal to -10. Does that make sense? How do I solve for a? Divide by that number, right? So I'll take -10 and I'll divide it by that number. Now it gives me 5.3 repeating. But 5.3 repeating is what, 16/3? So as a, and I don't want to use 5.3 repeating because I have to shorten that at some point, and I don't really have then the right a value. But now a is 16/3. So then this would be the polynomial that has those zeros, but also passes through point D. Does that make sense, everybody? Okay. And we can, because remember, there's an infinite number of polynomials that go through, if I take a times, what was it, x plus 2, x plus 1, x minus 1. Okay, all of these different polynomials pass through, and there's a lot more. My slider stops at -5 to +5, but all of those pass through a, b, and c, right? Okay, but they all have different a coefficients. The a, when a is, what's say, 16/3, it is the one and only one then that passes through a, b, c, and d. Okay with everybody? Now that's the same procedure that you would use up here, that you could use up here. So I go p of x, we said was a times x plus 3 times x plus 1 times x minus 2. Here is a third point, I guess in this case a fourth point, where -12 is your y value. X now is 0, so I have a 0 there, 0 there, 0 there, so I've got 3, 1, -2. What's 3 times -2? Be -6a, wouldn't it? If I divide that out and get a, doesn't it make a to be 2? Which is exactly what we figured out there. Now there's other ways of finding that 2, like we did in this question, but that approach is the default way that will always get you the right result. Okay, and then you can use that for, we can use that for quadratics, you can use that for cubics, quartics, quintics, whatever. It doesn't matter how large the polynomial is per its factors, because it's the same process. It's just multiplying maybe by another factor or another 2 factors or whatever. Yes? Yes. Does that help answer you guys' question? Okay. So in the one in the homework, it just worked out that this a, so like the picture they gave you was the graph going through like -6. So this a was a 1 and you didn't really have to worry about it. And it's just a coincidence.
Are we going to close tomorrow?
No.
Hold on 1 second.
No. Let's see here. There was a question, and the last class was having issues with it, and I can agree with their confusion on this. I just want to make sure that we cover, it's like 4 and 5 and 6 in that area. So I know 5 is one of them that does this. And I'm going to, yeah, because there's, so here, I just grabbed one that somebody in the last class did. And they are, what they have in gray there is absolutely fine. It's correct. If I multiply that out, it gets me back to my original P of X. Okay? But it's counted wrong. So I want to go through this process with you, and I want to explain to you why it's counted wrong and maybe how you address that and fix that. If this is on paper and pencil and you wrote in gray what they have, I'm giving you full credit on that. That's fine. Okay? But if you think about it, this is your, what we'll find out here in a moment is that is Q of X when we do long division or synthetic division. This is what we chose as D of X. And this would have been our remainder of X. Okay? But what are they saying that D of X was? 5x minus 7, which we're saying is not that, right? So it's looking for one of these factors over here to be 5x minus 7. So if you take a 5, is there a 5 in this right here? That is a GCF? Can you take that 5 out of there and leave you with x squared minus 1? And then you have this 5 back here, like that, when I factor that 5 out. Can I now distribute that 5 through there? And does that then generate the 5x minus 7 that they're looking for? So that's kind of the idea that's going on here. I just want to go through this problem real quick. Either synthetic division, long division. How do you guys want to do it? Synthetic division or long division? Long division is easier in regards to getting the right answer. Okay? We can do both. Let's draw the comparison between both of them. So if I go 5x cubed minus 7x squared minus 5x plus 0, right? Do long division. So what am I going to put out here? 5x minus 7. So that's my d of x. And this is obviously p of x. Okay? What needs to go right here? Put x squared there. So when I multiply by 5x, I get 5x cubed. Multiply by 7, I get negative 7x squared. Okay, so I'm going to change signs. Add straight down. That goes away, and that goes away, right? And that's fine. So we have a 0 there. We'll bring down now the things that we haven't used. Negative 5x plus 0. What do I then multiply 5x by to get this negative 5x? You probably you maybe don't have that 0 there.
No, I wrote the 0, but I wrote 0 minus after the x squared, just so I can calculate.
You what?
So I put.
You put a 0 here, so then I had to multiply by 0 to get a 0 lined up there.
Yeah.
Okay, that's fine. I'm not going to do it that way. I think that's kind of confusing. Because when we have a 0 minus or 0 plus anything, we don't need that, right? So now the next terms that I'm actually going to operate with is this one. So what do I need to multiply 5x by to get negative 5x? Negative 1. I see what you're doing. You're writing up here so you had a placeholder in your quotient. You can do that. There's nothing wrong with that, but it's not ultimately necessary. So then I'm going to take that negative 1 times my 5x and gives myself negative 5x. Negative 1 times negative 7 gives me a positive 7. Change signs. Add straight down, goes away, gives me a remainder of negative 7, right? So now if I did long division this way, I should not have any issue generating this because we talk about that being Q of X, right? This being R of X, and we already know D of X. So if I go D of X times Q of X plus R of X, I get exactly that, right? Does that make sense, everybody? Okay, it's when you do synthetic division, you remember what I said to you yesterday, if you use synthetic division, you lose a little, you gain efficiency, you gain speed, but you lose a little bit of context. And you also have to understand what are we really dividing by, or what are we trying to see as the factor ultimately in synthetic division. So if I do synthetic division here, we get a 5, a negative 7, a negative 5, and a 0. That's the coefficients of P of X. Now, what goes in the box? What goes in the box? 7/5 goes in the box. Okay? because what goes in the box, remember, x minus c equals 0. The answer to that equation goes in the box. X equals c. C goes in the box. Okay? So if I have 5x minus 7 equals 0, the answer to that equation, which is 7/5, goes in the box. Does that make sense, everybody? Okay. Remember that when we're done here in a moment. Bring my 5 down. Now, here's the nice thing about even though that there's a lot of times a fraction might go in this box, the multiplication is not all that difficult, okay? Because what happens here, we just get a 7, right? 7/5 times 5 is just the numerator. Gives me 0, multiply that, gives me 0, -5, and then we get -7, right? Bring down that, my remainder is -7, right? Okay, so when I do the synthetic division here, okay, this is what we've been calling Q of x, right? This is what we've been calling R of x, and we would say x minus 7/5 is if it gave a 0, we called that a factor, okay? But it is what I was dividing by, right? Okay, so maybe we call that, maybe incorrectly in this problem, we call it d of x. Now here's the issue. If I write this if I consider that d of x, this q of x, and this r of x, x minus 7/5 times 5x squared minus 5 minus 7, okay, where this was our d of x, this is what q of x was, and this is r of x, we are going to get something that was different than that right there, correct? Or looks different. Now, just real quick, and we'll cheat doing this. If I take and I say expand 5x minus 7 times x squared minus 1 minus 7, I ask you to expand that. See if you can find it. Get rid of all this other garbage. I get that right there. Is that what we started with? Okay. If I ask it to expand the bottom one, the one we did through synthetic division, x minus 7/5, 5x squared minus 5 minus 7, does it give me the same thing? Yes, it does. Why is it counting this one wrong? Because that's what they got typed in here, right? Why is it counting it wrong? You got to think about how this was programmed. They told you d of x was 5x minus 7, right? So they want you to use that d of x. Okay, even though these are two equivalent formats, they want 5x minus 7 as being the factor. So just the way it's being programmed is that it has in the background, the way they create these questions is through variable terms. So in the background, they might have like variable 1 times variable 2 minus variable 3, representing 5x minus 7 times x squared minus 1 minus 7. And they say, only count this correct if user's variable 1 equals 5x minus 7. I mean, you don't have that. You have x minus 7/5, and you have the 5 then in another factor. Does that kind of make sense? But they're fine. They're okay. They're both the same. And like I said, if you're doing this on paper and pencil, I don't care. You can do either or. Okay. We did in the last class. We kind of thought about this way. Just want to make sure that we don't do this. If I go ahead and factor this and I get this to be q of x, so 5x squared minus 5 minus 7, and then I do use the d of x that they said, which was 5x minus 7, instead of using this here, okay, what is the problem with that? If I multiply everything out, I get 25x squared, right? Okay, which is a problem because, x cubed, sorry. So you get 25x cubed. You would have also gotten, when you FOIL, you would have gotten that to be a 35, and you would have gotten that to be a negative 25. Does that make sense? So everything would have been 5 times as big because you have here, you've brought in either an extra factor of 5 in this factor or in that one. You have to just realize that and take it out of one of them. Okay, so on a test or a quiz, guys, like I said, I don't care which one of these you have. I would fully agree with both of them. Okay, and to be honest, what's going to actually be of benefit to us eventually is to bring that 5 out of everything and really write it this way: x minus 7/5, x squared minus 1, and then put that 5 out front. That's going to be more beneficial to us. Okay, because that directly tells me, especially when that 7 or negative 7 is a 0, that would tell me specifically where I cross the x-axis, and that's what we want eventually. Does that help with that question? Or questions like that? You guys have anything else? Any other questions on here that were confusing? If not, we'll have a little time tomorrow to answer questions. So remember the questions that we were doing, and even in your homework you see some where they've got, let's see if I can demonstrate this real quick. So question 13 in your homework. Question 13 in your homework asks something like this. Okay, the first thing I want you to realize is that this box right here, or there is a box, I guess I'm viewing it a little different way than you guys see it, but there'll be a box here to type stuff in. What they were wanting you to do is to type in your synthetic division. Don't do that. Just skip it, okay? That's kind of what we talked about yesterday. But here, they're telling you that you have 2 zeros. They're saying show that the given values of C are zeros. Show that -1 and 3 are zeros. So you go through your synthetic division, and with those being the values that are in your box in synthetic division, you'll get a remainder of 0 for both of them. Okay? So that's the demonstration that they're both zeros. Well, that allows us, because there's 2 of them, that allows us to depreciate this original polynomial down to something that is squared. And if it's down to something that is squared, a quadratic, you have factoring tools that allow you to factor that quadratic and eventually come up with the other 2 zeros. Okay? Now, they get the ball rolling. They tell you essentially the question here, if we're going to rewrite it, would be completely factor this polynomial, knowing that -1 and 3 are zeros. Today, I'm going to say completely factor that polynomial. And I'm not going to give you any previously known zeros. Does that make sense? So we have to have a ability to realize those, to generate those. Okay? And that's what I'm trying to demonstrate a little bit with you today. Okay? So 3-4 talks about real zeros of polynomials. Okay? And we're going to have what we call the rational root theorem or the rational zeros theorem, which deals with if we have rational zeros, the practice that we go through today is going to identify them for us. Okay, but it also might identify things that are not rational zeros, and that's the conundrum that we come across, is that we might end up with a list of 40 things that could be zeros, and only 3 of them actually be zeros. Okay, so what we find out then is a guy named Rene Descartes. Have you guys ever heard of Rene Descartes before? Okay, what is attached to his name? What is named after him? Somebody on the last class said the rule of signs as well. Carts, yeah, shopping carts, named after him. He made shopping carts. Did you know that, Ty? Yeah, he's the guy. You knew that, right? Have you ever heard of the Cartesian plane? You think so? I know you've heard of the Cartesian plane.
I don't know what it is, though.
How do you not know what it is? I've taught you before.
Is it like just a plane in geometry? Coordinate plane?
Which is the X and Y axes. Okay, the XY plane
I don't know what that
is.
What's that?
I've seen your grades. You're probably being accurate.
98?
So the XY plane Okay, this thing right here, correct? Okay, Rene Descartes created that, okay? And it's called the Cartesian plane, okay? If we were to like identify maybe the top 5 or 6 mathematicians of all time, Rene Descartes in that list, okay? He's probably number 5, I'm 1 through 4.
He's not in my top 5.
Well, he's not your, who's your top 5?
Probably Jim.
Jim? All right. So what happens here is these 2 rules, they're going to be tools that we use to dwindle our possible zeros list, okay, that we generate here in a little bit. Now, because of the advent of technology, a lot of people don't use those anymore, but I do want you guys to see them being used a few times, okay? Yesterday, we learned that the factor theorem tells us that finding the zeros of a polynomial is really the same thing as factoring it into linear factors, okay? That's what the homework is collectively trying to get us to realize. So in this section, we study some algebraic methods that help us find the real zeros of a polynomial and thereby factor the polynomial. So after 3, 4, we should be able to factor any polynomial we ever come across, okay? But I'm going to begin this with hopefully a little bit of a exercise that gets you to understand to some extent why this theorem works, okay? I have the proof somewhere. Now the proof is, I've written it out. It's kind of messy, and then I lost it. Okay, I lost my one of my notebooks, and it's in that notebook. So I got to find that, and I'll get the proof to you at some point, and we'll walk through it. But I'm not going to do it by hand with you right now because it's very messy.
I believe you. You don't need the proof.
No, I want you to see it because I want you to see that algebra because that's real algebra. This is, I don't want to say this isn't real algebra, but when you get to like college and you're doing
It's college algebra.
right, but I mean, we're practicing specific problems. When you get to, like, you're focusing solely on algebra in college, you don't do a whole lot of specific problems, okay? You do a whole lot of proving theorems and procedures and that kind of stuff. So, to help us understand this theorem, let's consider this polynomial right here, okay? 2 different versions of it. We've got the factored version, we've got the expanded version, right? Okay, they produce the same exact cubic function if we graph it. Okay, but they're a little different. How do I get from here to there? I distribute. Okay, I take x minus 2 times x minus 3, get a product from that, and multiply that by x plus 4, right? And that will give me x cubed minus x squared minus 14x plus 24. In the event of doing that, if I take and multiply these together, what would be last times last in those 2? Positive 6. So I got 2 terms here and a plus 6, right? And then I would multiply that by x plus 4, right? What would last times last be there? Gives me that 24 right there, correct? Now, so if we can see that, we can see that this times that gives me that number right there, correct? Okay. What was the value 2 for my polynomial? If I look in the factor form, that value 2 is a what? X minus 2 is a factor, so 2 is a 0 or an x-intercept, right? 3 is a what? 0 or an x-intercept. Negative 4 is a what?
Same thing.
Same thing, okay? So, do all those numbers, those numbers multiply together to give me 24, right? So what does that mean they are for the number 24?
Factors.
They're factors, okay? Meaning they divide 24, right? Okay? So if we have 0, what this is showing, if we have zeros for our polynomial, okay, they are factors of that 24. They are factors of our constant term in our expanded polynomial. Does that make sense? Now that works you're going to say, well, you just gave me one specific example that before class you manipulated, so that would work. So let's do it this way. Computer algebra system or solver? And right now it's got me, there we go. Had me in probability there for a minute. All right, so I'm gonna create some sliders. I'm gonna create slider A. Let's create a slider called B. And I'll create a slider called C. Okay, so now I'm going to just type in x minus A. X minus B, X minus C, and it gives me that, which if I change these sliders, then you can see, there we go. And I want to keep it in. So it's going to, for whatever reason, expand it here for me. I don't want it to expand it, but it's going to do that. So the A, B, and C here, so this would be x minus 2, x minus 3, x minus 4, right? Would you agree that 2 times 3 times 4 gives me negative 24? What if I do something like that? Would you agree 2 times 2 times 4 gives me this 16? That makes sense to everybody? Okay. The 2 times 4 times 8. So now why doesn't it expand that one? So let's go. Do you agree that 2 times 8 times 4 gives me 64? Okay. Now, that is when our A coefficient is 1 out here in front. Okay. There is a little bit of a difference when I make this like a 2 right here and expand that. Now, 2 times 8 times 4 doesn't give me 128. Okay. In my proof that I will show you at some point when I find it, will explain that factor of 2. And the why I need that, if I take that factor of 2 and divide 128 by it, I get down to that 64, correct? Okay. So what I want you to realize is that when we have a polynomial in expanded form, because that's what we're going to start with, we're going to try to factor that. Then if there are real zeros, or there are places that this thing crosses the x-axis, then those places are at factors of that number right there. Okay. Now, that being said, what are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. How many we got there? 10? 8?
Yeah.
We got 8, and we actually have 16. Because they're plus or minus. Okay? So, the factors of 24 within that list exist zeros, potentially. Does that make sense? If our polynomial is going to cross the x-axis at a rational number, then it's going to do that only at those values, potentially at those values. There's no way that it's going to be able to pass through like a rational value of 9, because 9 is not a factor of 24. Does that make sense? Okay. Now there's only 3 that it passes through. So what we have to do is somehow determine, how do I dwindle this list? How do I get to this 2 and to this 3 and to this negative 4? Okay. Remember yesterday they would say, C is -1 and C is 3. Okay. Well, they knew those because those values right there came from a list like this. Does that make sense? Okay. So now how do we make that list when we look at any polynomial of any degree and with any coefficients? Now, I want us to be cautious here because it says if the polynomial p of x, which is equal then to our generic polynomial function, has integer coefficients. What does that mean? Can't have what? Can't have fractions. Okay? Which kind of stinks, right? So what this is saying then is that, well, Mr. Fay, you said we could factor any polynomial we ever come across, but if it has like 1/2 x to the third, I can't do that. That's what that says right there, right? You guys agree with that? Okay. Well, let's do this real quick. Let's say that I've got, and you may at some point have to do this. Let's say we go, I'm going to ask it to expand, like x plus 1, x minus 2, x minus 3, x plus 3. All right, and now let's go back through and put let's do it this way. This will make more sense. One fourth x to the fourth plus 2/3 x to the third minus 1/2 x. And then we'll go minus 2. Let's go minus 3. Okay. Now we'll go, that's fine. All right, so that's my polynomial. Okay, and per the theorem that we just introduced, and we didn't get through the whole theorem, we just read the first sentence. And the first sentence kind of makes us think, well, this is only going to work sometimes. What could I do with that to get rid of that 1/4? Multiply by 4. What could I do with that to get, so if I multiply everything by 4, does that get rid of the 2/3? No, what do I need to multiply that 2/3 by? 3. So then I'd have to multiply the whole thing by 12 so far, right? Does that 12, when I multiply by 12, does that get rid of the 1/2 as well? So let me do this. Let's take 12 times f of x. What do you notice about those two graphs? They have the same intercepts. And that's what we're trying to do, right? We're trying to factor this thing. And the way that we factor it is through the knowledge of understanding what the x-intercepts are, what the zeros are. Okay, because if we know what a zero, then we know a factor, correct? So if they start you with a polynomial that has non-integer coefficients, you can turn them into integer coefficients through multiplication. And you're still going to get the right zeros. Does that make sense? Okay. And then when I'm done, I would have to then account for that 12 that I ran through that thing. And I have to divide that back out and get rid of it. Okay.
Teacher, students, pardon interruption. Those students who have Mr. Miller for 4th period government will report to the library for 4th period today. Again, Mr. Miller's 4th period government class will report to the library, and the remainder of his classes will be in his room for the rest of the day. Thank you.
So tomorrow, I was pacing myself because my clock is, I thought I had 5 more minutes. Tomorrow we will get into what P stands for, what Q stands for, and their P is the factors of this 24. And Q is the factors of this number out in front, your leading coefficient. Those then, everything that is P over Q, then is a potential zero of the function. Okay, and we'll run through some examples of that tomorrow. Also tomorrow, make sure your computers are ready to go. We're going to do just a quick run through of working with Schoology in the event that we get moved to hybrid or fully remote or whatever. I just want to make sure. I know some people have never looked at Schoology because they're here every day and they don't need to. Okay, so I just want to make sure that we have that tomorrow. We'll take about 5-10 minutes to do that, and then we'll do all these examples and maybe some homework questions if you got homework questions. Is that cool?